All right, so we're working with the parallel lines and transversals. So remember, we got our two parallel lines, line through it. That's the transversal. When I give you 1 point, or not 1 point, one angle, we should be able to fill in every single angle that's missing. All right, what we have to be able to identify is which ones match, which ones are the same. Okay? So when we look at this, I got my 65 here. If I look at the angle right next to it, is the 65 smaller or bigger? Smaller. We're looking at like the opening on the angle, okay? So that means the 65 is the smaller of the two angles. Out of these 8 angles, at each of these x's, there's 4 of them, we have 2 different measurements. One is smaller, one is bigger. All of the smaller ones are the same. So if this is 65, that's a vertical angle straight across, that's 65. Bottom right, 65. Corresponding angle on the bottom right, 65. 65 here. All of those are our smaller angles. All of those either are corresponding or vertical angles, depending on which way we did it. So all those are 65. Everybody good with that part? Now we need the other angle. Well, the two angles that are next to each other are linear pairs. They're going to add up to 180, right? So if we do 180 minus 65, in this case, that gives us 115. And what that tells us is every one of our bigger angles is 115. Okay? Everybody good with that? We have all 8 of the angles filled in just from one angle. Now, what it's going to do, though, is it's not going to ask us for all 7 of the missing ones. It's going to ask us for like one specific one. So go ahead and give this a try. Find the value of x. Greg, what you got? 75 is correct. The 105. 105 is the big angle. So we got big angle. The x down here, we can tell that's the smaller angle, right? Everybody clear on that? That means they are different. If they are different, the two of them have to add up to 180. So we do 180 minus 105. That makes 75. Okay? Any questions on that one? Don't worry, they'll get a little tougher. So, like I said, get a little tougher, right? Now, here's how this works. It still starts off basically the same as we did for the one before this. Are those different or the same? They're the same. 72 is the smaller angle. 4x minus 12 is the smaller angle. Everybody clear on that part? If they are the same, what's that mean? Well, they're equal to each other, right? So in this case, yeah, they're going to equal 72. So if I make 4x minus 12 equals 72. Everybody good with how I got that equation? They're both the same, so we set them equal to each other. If you're using Desmos, you put this into 2 equations. That's one line on Desmos. The other side is going to go on the other line. Remember, when it's just a number, you need to put y equals, right? If we're going to solve this without Desmos, we just solve by doing opposite. So I would add 12 to each side. So I got 4x equals 84. I divide by 4. I got x equals 21. Okay? Any questions on that one? Like I said, we're using Desmos for today, so if you put those into Desmos, that'll get that for you. But you're looking for the x value each time when you put them into Desmos, okay? So, you get the ordered pair where they cross, we're looking for x. Any questions on that? So that's when they're the same. We set them equal to each other. This one, are they different or the same? Same. They're both big angles, so give it a try. Get your answer. We're finding the value of x on these. David, what you got? X equals 17 is correct. So since they're the same, we got 6x plus 7 equals 109. Everybody good with that part? Desmos, you'd have 6x plus 7 on one line, y equals 109 on the other. You're looking for where they cross. To solve, I subtract 7. I got 6x equals 102. 102 divided by 6 gives us that 17. Okay? Like I said, a little step harder than what we were doing yesterday. Still not like maybe a whole lot to it. All right, what about these? They're different. All right, so they also, I don't have a number for one of them. I've got an expression for each of them, right? So when they are different, if I have two angles that were different on here, the two angles have to add up to 180, right? It's the same thing for this. They got to add up to 180. So I take my two expressions, I add them together, and I set them equal to 180. Okay? So when they're the same, you set them equal to each other. When they're different, you add them together and set them equal to 180. So when I combine these, I've got 11x minus 18 equals 180. I add 18. So I got 11x equals 198. When I divide by 11, I get x equals 18. Okay? On Desmos, that goes on one line. Y equals 180 goes on the other. And again, you're looking for where they cross. We're looking for the x value. You will, on a lot of these, have to zoom out some because, we need y equals 180, so that's going to be pretty high up on your Desmos graph, right? Any questions there? What about these? Are they different or the same? These are the same. Both a big angle. They're vertical angles. They're across from each other. So when you solve these, you set them equal to each other. Go ahead, give it a try. What you got, Levi? Yeah, we got x equals 7. So we set them equal to each other. That would be the equation we have. 15x minus 2 equals 13x plus 12. If you had it flipped around, that'd be fine too. 13x plus 12 equals 15x minus 2. It's the same thing. If you use it on Desmos, left side goes on one line, right side goes on the other. You're looking for where they cross. Without Desmos, we got to move the variable to get it to the same side. We want to move the lower one. So 13 is the lower. Those cancel. 15x minus 13x is 2x. We got the minus 2 equals 12. Add 2 to each side. So I got 2x equals 14. When we divide, we got x equals 7. Any questions there? All right, so this one's a little different. What's different about how this looks? We got that y there. So on problems like this, what they're doing is they're asking for the measure of angle y. Okay? So this is what we're going to have to find. What number goes there? Before we do that, we have to find x. Okay? So is x, are these two angles with the x's? We're ignoring the y for right now. Are these two angles with the x's different or the same? Different. So that means they add up to 180. So we got 6x plus 11 plus 3x plus 7 equals 180. All right, so you can put that into Desmos. Go ahead and put that into Desmos and see what you get for the x. What's x equal? No, not 8. Yeah. So we got x equals 18. Anybody not sure how we got the 18? So when we put this into Desmos, on one line on Desmos, we're putting the 2 added up. All right, so first row of Desmos, you would have 6x plus 11 plus 3x plus 7. Okay? When we have it equal to a number, our second equation, the second side of our equation, we need to put y equals. So if I put y equals 180, you're looking for where those two lines cross. And we're looking for the x value where they intersect. In this case, the x value is 18. All right, so now we got x equals 18. Remember, that's not what this question's asking us for, is it? It's asking us for the measure of angle y. So, to get the measure of angle y, which of those is the same as angle y? The 3x or the 6x angle? The 3x. They're vertical angles, they're across from each other, that means they're the same, okay? So what we're going to do is we're going to take this 18 and we plug it in. So I got 3 times 18 plus 7. Everybody good with that? That's all we're doing. We take it, we plug it in. So 3 times 18 is 54. 54 plus 1 is 61. That means, oh, sorry, plus 7. My fault. I was skipping ahead. I knew it was 61. So, all right, everybody good with that? You can put that all into Desmos at once you get the value for x, okay? We can do 3 times 18 plus 7 in one row. Okay? Couple steps to it, right? Not so bad, though. All right, try this one. Find the measure of angle W. Or tell you what, find x first. Find x first. We'll do it in pieces still. Find x. Are those different or the same? The x's, are they different or the same, those two angles? They're the same. So set them equal to each other. Blanca, what's x equal? 17's correct. All right, anyone not sure how we got 17 there? When they're the same, you got to put each one of those as a different row on Desmos. So we got the 8x minus 25 on one line, 6x plus 9 on the other line. You're fine where they cross. And when they cross, you're looking at the x value, okay? So now that we got the 17, we're going to have to plug it in. Here's what's different about this one. Is W the same as either of those? No, W's different, okay? So we're going to have a little extra to this as well. So go ahead and plug it in for one of those two angles, either with the 6x plus 9 or the 8x minus 25. So plug it in there, see what you get. Greg, what'd you get? 111's correct. 6 times 17 is 102 plus 9 is 111. All right. Anybody not sure on the 111? Okay, who thinks they can tell me what W equals then? Hmm? Yeah. So W is going to equal 69. Anybody not clear where the 69 comes from on that? All right, so look, we'll clear this out. This is 111 there. Everybody good with that? So if I say that's 111, remember, what's that mean? Every big angle is 111, right? The little angles then, we do 180 minus 111, right? So that makes the angle next to it 69, because 69 plus 111 is 180. This is a little one, right? So we got the 69 down there. Y'all, that problem right there is pretty much as complicated as these get, okay? Most of them are solved for X kind of problems. Any questions on that?